Hi, I'm Dr. Chloe LeGendre. I'm a senior software engineer at Google Research. Okay, so it's an interesting story that involves both an academic conference as well as an issue of the New Yorker, like the magazine. So I went to my first SIGGRAPH, which is the big computer graphics conference, in 2013. And when I was there, I learned about all kinds of interesting work, some of which was happening at ICT, but I didn't necessarily know that that was where I was going to end up to do my graduate studies. I was getting a haircut in the town where I lived at the time in New Jersey, which was Hoboken. And on the table in front of me was an issue of the New Yorker. I picked up this issue of the New Yorker, and inside there was an article that was called Pixel Perfect, which was an article that was outlining the work of Paul Debevec and the graphics lab in creating virtual humans. I was already loosely aware of the work from my time at SIGGRAPH, but I didn't know nearly as much about it as what I learned from that article. That was, I believe, in roughly like the spring, early summer of 2014. And that was the point where I decided, wow, if I'm going to go back to school and, go to graduate school, this is where I want to do my work. I want to do this at ICT, and I want to be working with Paul. I got the call at some point, or an email from Kat Haas of the graphics lab, that they were interested in my profile after I'd already been accepted. I was just flabbergasted because I had seen the work at SIGGRAPH before. I knew about the work, and then I had read about it in that New Yorker article. And I was just blown away. I just knew that I wanted to come here. And so kind of instantly from that point, all of the other schools that I got into were like not even something that I considered. And within like a few months of me working here and having my desk right across from the lab, there were just like an army of incredibly famous people coming in and getting their face scanned. And I was just like, I had just moved to Los Angeles. And I was like, this is a pinch me moment to be involved in an academic research lab that's also so integrated into these Hollywood productions. One of the pieces of work that I was most proud of from my time here at USC ICT was our practical multispectral lighting reproduction, which we published at SIGGRAPH in 2016. This was work where we took the light stage, which previously there were techniques that you could use the red, green, and blue LEDs of the light stage along with the white LEDs of the light stage, which were used for the facial scanning, like the high resolution facial scanning. We were able to take additional spectral channels, which were the white, the cyan, and the amber LEDs, and drive those to reproduce real-world illumination inside the light stage. So we had this really cool shot where we had a friend of the lab, this woman named Janetta. She came and we photographed lighting environments outside ICT, kind of golden hour time of day. We reproduced that lighting inside the light stage, and then we filmed her inside the light stage as well. And if you do the side-by-side of like, this is Janetta outside and this is Janetta inside the light stage, it matched just perfectly. Previously, you'd have these like color rendition errors, which maybe you could correct them with applying some kind of color grading or color matrix technique. But ours, we didn't have to. It just came out of the camera, and because of all the calibration we did, everything just matched. I'm now going to be the posters chair for SIGGRAPH 2025, and this is something that's like, it was just so cool because this was one of the things that I was really involved with in my time here at USC ICT, was contributing to this posters program as well at SIGGRAPH, and now to be able to chair that is just like, it's so cool to be able to involve kind of the next generation of researchers in this work. But kind of after I graduated, one of the roles that I had was as a research scientist at Netflix, and I was working there with Professor Paul Debevec as well. And we were looking around and seeing that this was especially in the kind of post-pandemic era, a lot of production was moving to the virtual production using LED walls. And LED walls are amazing because they allow you to practice lighting reproduction as well. So you're literally surrounding the actor with the light that would be illuminating them out in the real world as if you weren't in the studio. This is one way that you could practice with these LED panels, that you could practice this technique. But the challenge there is that these LEDs, again, are only red, green, and blue. And so you can't use our multispectral lighting reproduction technique there because you don't have these extra spectral channels. And so we wanted to sort of solve this question of, well, if you don't have these spectral channels and you have to kind of fix it in post, what's the best way of doing this? And so this was work that actually, there is really a through line from the work that we did at ICT to this final work of how can you get the colors looking correct on the actor when they're lit with the lighting of the real world that you would capture outside. How do you get that right, but also have the in-camera background that you're filming look correct, color correct as well? And so this was some of the work that we published. I think it was in 2022, I believe, and it was at the DigiPro conference, which is the Digital Production Symposium, which is co-located with SIGGRAPH as well, but kind of more focused on, I would say, industry applications. So at Google, I am a software engineer, but I work in the research organization. And so what I'm trying to do there is leverage my knowledge in imaging and computer graphics, as well as machine learning, to develop new technologies that will eventually ship in support of new features on the Google Pixel phone or in the Google Photos app primarily. And so I've been involved with several products that have already shipped. One of them was Portrait Light. This allows you to kind of position an artificial light into your photo after capture so that you can, again, kind of fix it in post. I was also involved with a second kind of version of Portrait Light, which is called Balanced Light, which allows you to remove the appearance of harsh shadows in images after you've captured them. So those are both photos that are a part of, those are both features that are a part of Google Photos. And so those are examples of things I've done in the past. Things I'm working on in the future are in similar domains. Can't talk about them fully yet, but they're applying kind of computer graphics and lighting-based ideas to improve photographs largely after capture. And how can we do this? Typically, it's using machine learning techniques.